Hello friends, my name is Harshit Dwivedi and I again welcome you all to my video tutorial. In today's video tutorial, I will tell you about a topic named percentages. This is one of the most important topics of quantitative aptitude, be it the exams of SSC, CGL, CAT or any other exam, especially PO. And when we talk about the relevance of this topic, percentages, this topic is relevant from the viewpoint of many different subsections. First of all, when we look at the questions of quantitative aptitude sections, there are many questions that are involved in the concept of percentages. Second thing, if you are not clear in this concept of percentages, if the concept of percentage is not clear to you, then you are going to face problems in these topics. First of all, you can face problems in topic of SI, CI. Second of all, you can face problem in topic of profit and loss. Third, you can face problem in data interpretation. So on. So these are the three main topics in which you are going to face problems if you are not clear with the concepts of percentages. So in this chapter, I will start from the very basics of percentages and I will cover in detail all the concepts of percentages relating to the concepts that are given to you in the books. If you are going to look all the videos of these percentages, initially I will tell in these classes about the concepts of percentages only. Their real application and questions I will upload later on. So let us start with this topic. And I would like to explain you it in a very basic way. That means if this video is being watched by any student who is at a bit advanced level, because this video I am making from the perspective of those students whose very basics are not very much clear, so that they become very much comfortable with this topic percentages. All those students who are a bit versed with this topic, they do not need to watch this video, because in this video I am going to cover some very basic concepts. After, in the subsequent videos, some difficult concepts of percentages will be placed by me in front of you. So the first of all, if I say there is a number n and I say that I have to increase this number by 20%. This is my question. What is? If n is a number and I have to increase it by 20%. Let's suppose it is not 20%, I take a very general term, I take p%. So there is a number, initial number n, I increase it by p%. Then what will be the final number that I will get? The final number will be n into 1 plus p upon 100. This is a very basic thing. There is a number n, I had to increase this number n by p%. So what I did? I used this formula. N into 1 plus p by 100. How this formula was derived? The fact is that n was initially present. And if I have to calculate the percentage of n, that is how much is p percentage of n, then how can I calculate it? It is p% of n will be equals to p into n by 100. P percentage of n is equals to p into n by 100. Second, if n is to decrease by p%, then what formula we are going to use? The formula will be same, the sign will change. Obviously here this is plus, now it will be something like this, 1 plus minus of p by 100. So it will naturally, the formula will become something like this, n into 1 minus p by 100. So in the case of decrease, it is minus. In the case of increase, it is plus. Obviously, we know that when something is increasing, we have to add a certain amount of quantity to it. So that quantity will be that percentage which we have increased. So what is that percentage? That percentage is p% of n. That is p into n by 100. And I will add this quantity p into n by 100 plus n. So what will it become? N plus p into n by 100. When I will take n common, I will get 1 plus p by 100. This is the concept. And similarly, when I decreased it, what I have to do? I have to decrease this quantity by n. So in that case, what it will become? N minus of p by 100. So in that case, it will become minus. These are two different cases. N into 1 plus p by 100 is a different case. N into 1 minus p by 100 is a different case. 1 plus p by 100 is in the case of when a number is increased by p%. 1 minus p by 100 is a case of when a number n is decreased by p%. This is the simple logic behind this thing. Now let us understand this thing by relating it to our daily lives. The very important thing about these topics of basically arithmetic, like you can say profit and loss, percentages, and numbers to a certain limit, and also time, speed and distance, time and work. So these are that sort of topics, the concepts of which you can relate to daily life. Other topics, such as if I say a topic of say functions, okay, or if I say a topic of say geometry. So functions and geometry, these are those type of topics, and basically also probability. These are those type of topics which we do not generally need to relate with our daily lives. Especially if we talk about probability, some amount of relation can be there with the functions that we perform in our daily life. But the concepts of geometry and functions, they are not at all applicable to the daily happenings of our life. So these things, the best way of studying percentages, time, speed, distance, profit and loss, time and work is to relate the concepts of these topics with your work of daily life. You can easily then have a command of in it, because in that case, even when you are not studying and doing your normal work, then also you are basically brushing up your concepts of these topics. This is the point. So now moving forward, I will take an example. The example is something like this. Suppose that we all have given our 10th class. In the 10th class, we say that a guy scored 83% or 82.8% or 82.4%. So by that example, we are going to understand the concept of percentage. What does this word percentage means? The word percentage meaning is comparing any quantity, fixing the base quantity as 100. This is what is the meaning of percentage. Percentage means that comparing any quantity, fixing the base quantity is 100. That means that we calculate the value of any particular quantity not in the absolute terms, but in the terms if it is measured on a scale of 100. That means the total quantity is normalized with respect to 100, and with respect to that 100 the original quantity is measured. This is the whole logic beyond percentages. Suppose if I say that all of you have given, if you have given your board exams from CBSE board, you know that in the 10th class final examinations, what was the total marks? The total marks were, there were 5 subjects, 500 marks. This was the final paper, 500 marks, and out of these 500 marks we have to, you say we got numbers. So suppose a guy got 407 marks out of 500. Suppose his performance was actually, someone scored 407 marks out of 500. So what is his percentage marks scored? This is the question. 407 marks out of 500 marks he scored. What is his percentage marks he scored? So if I ask you that what are his absolute marks, what will be your answer? 407. But if I asked you what are his percentage marks? So now coming on to this definition of percentage. In percentage, I told you that percentage means comparing any quantity, fixing the base quantity at 0. This is what percentage means. That means you can also say this base as total quantity. Base, total, it means the same thing. You know, the denotation is different, but the overall theme is the same. The point is, percentage is the calculation of a value normalizing the total quantity or the base quantity to the scale of 100. This is what it means. So here, I have to calculate that how much percentage marks is this. That is, suppose Sohan scored. Sohan scored 407 marks out of 500. So what is Sohan's or his percentage marks scored? So what are the total quantity here? The total quantity is 500. The total quantity is 500. So what is our first step? That I have to equate this 500, or I have to normalize this score of 500 to the scale of 100. And after normalizing this 500 to the scale of 100, I will calculate that what will this 407 go down to. So in order to make 500 equivalent to 100, here some concepts of unitary method will be used. Unitary method. That if 500 is equivalent to 100, if 500 marks is equivalent to 100 units, then 1 mark will be equivalent to, don't say it U, say it P, or say it 100%. If 500 marks is equals to 100%, so how much will be 1 mark equal to? It will be equal to 100 by 500%. This is the logic. If 500 marks are equals to 100%, this is the whole point. I have to normalize this base quantity, this total quantity to a scale of 100. So what is the total marks? 500 marks here. So this M denotes here marks. 500 marks correspond to 100%. 1 mark therefore will correspond to 100 by 500%. Well, how much he has scored? He has scored 407 marks. So 407 marks will correspond to 100 by 500 into 407%. Solving this equation, what will I get? I will get something like this. 81.4%. So the answer, how much percentage marks is Sohan has scored? So Sohan has scored 81.4%. This is the whole logic. So again I am going to repeat this thing, that if someone has scored 407 marks out of 500, so I have to normalize this score of 500 to the scale of 0. So I suppose 500 marks equivalent to 100%. So automatically 1 mark will become equivalent to 100 upon 500%. So 407 marks will become equivalent to 100 upon 500 into 407%. So it comes out to 81.4%. This is the whole logic beyond this thing. Suppose, let us take one more example. Before taking up that example, I will like to say to you that when there is also a shortcut of doing this thing, that if you have to normalize this score of 407 with respect to 500, then if you are wanting to make this 500 as 100, so the thing is that if you have to calculate that 407 is what percentage of 500, this is the question. We can also say that the question I told you, that Sohan scored 400 marks out of 500. So what is his percentage score? This question can also be something like this, that what is how much percent is 407 of 500? The question is same. You can also write this question as how much percent is 407 of 500. These two questions are the same thing. And if you have to answer this question, there is a very simple method. Given quantity upon total quantity into 100. This is the simple method to calculate the percentage. What is this? GQ gives us given quantity. What is TQ? Total quantity. And into 100, because we are measuring these quantities to the scale of 100. Obviously, I am writing quantity as in general terms here. Obviously, this quantity, total quantity, is the total number of marks scored in this space. And also, what does this give us quantity? This was the total number of marks and this is the number of marks scored. So 407, that is given quantity, upon 500, that is total quantity, into 100. What we can write it as? We can write it as 407 upon 500 into 100. It is the same thing, 81.4%. The whole thing is the same. You have to understand from the perspective of different viewpoints. The point is that when you will be attempting the exam, these type of questions, these type of data will be given to you in various numerous different forms. So in that scenario, you have to understand those forms in order to solve these sort of questions. Whether it is in the case of mixture, whether it is in the case of, you can say, basically in the case of marks calculation, or whether it is in the case of, you can say, basically any data interpretation questions, that in this year it is 2100, in 2007 it is 100, in 2009 it is 2400, so how much percentage increase is there? So these things can be in front of you in numerous other ways. So in order to understand or solve these questions in all forms, you have to understand the base concept, and in order to do that, you have to solve a whole lot of questions of these topics. I am not covering the questions here, I am sorry for that. Questions will be uploaded later if these videos are liked by you. Till then, let us first, I should complete the concepts first. Now before going on to the next formula of percentages, I will like to relate this concept of percentages with a small concept of mixtures. I have not reached the chapter of mixtures, but still at this point of time I will like to tell you a small concept here, so that it is useful for you in your curricula. Suppose it has been told to you that in a mixture of milk is to water, milk and water, milk is to water is 3:5. There has been told to you that there is a mixture of milk and water, and the ratio of milk is to water is 3:5. Now, a small concept of ratios, small concept of mixtures, all is involved here. Point is, I have not told you the ratio here, but all of us know that some amount of basics of mixtures we know, ratios we know. If you do not know, I am sorry for that. I will discuss this in detail in my lecture on ratio and proportion. Here, the question is, first question, what is the percentage of milk in the solution? Second question is, what is the percentage of water in the solution? So how you are going to calculate it? Milk is to water is 3:5. Now, the very basic thing of solving ratios is that if it is given in the ratio 3:5, this corresponds that 3 and 5 are not absolute quantities. Then in order to make them into absolute quantity, I multiply the respective numericals by a constant and assume that multiplying these 3 by a constant and 5 by a constant, I am going to get the absolute quantity. So for this, I made the absolute quantity of milk as 3K and water as 5K. This concept I know is not clear to many of you guys, but be a bit patient for about this. I will tell you how I did this 3K and 5K. So milk is to water become 3K is to 5K. So the quantity of milk is 3K, quantity of water is 5K, liters I suppose, liters. The total quantity will become 8K liters. So the total quantity becomes 8K liters, milk is 3K liters, water is 5K liters. So I have to calculate the percentage of milk, that is 3K liters. So what was the traditional method? I have to benchmark the base quantity of the total quantity to the scale of 100. What is the total quantity here? 8K liters. So I will assume 8K liters equivalent to 100%. This is liters. So 1K liter will be equivalent to 100 by 8%. How much I have to calculate? I have to calculate the percentage of milk in the solution. What is milk? 3K liters. So 3K liters will correspond to 100 by 8 into 3. So what it will become? It will become something like this. 300 by 8%. This is the percentage of milk in the solution. This whole derivation is for milk. Let us see it for water. Obviously, if in the case of percentage, we are benchmarking the total quantity to the scale of 100. So obviously, if this thing has come out as 300 by 8%, what will water come out as? Total quantity is 100%. Milk has come out as 3%. So water will come out as 100 minus 3 by 8%. It will be somewhere like this, 500 by 8%. Or you can also do it in the same way. 8k corresponds to 100. So 1k corresponds to 100 by 8. So 5k will correspond to 100k, 100 by 8 into 5k. That is 500 by 8%. So both the things are the same things. Milk, water. In the case of milk, the percentage came out as 300 by 8%. In the case of water, percentage came out as, total percentage was 100%. Only two things were there, milk and water. Milk's percentage is 300 by 8%, so water percentage will be 100 minus 300 by 8%. That is 500 by 8%. There is a very direct method of doing this thing. What was the total quantity? I told you, given quantity upon total quantity into 100, total quantity is 8k. Given quantity is 3k into 100. These thing and this thing, these are both the same things, so the answer will be same, 300 by 8%. Similarly here, total quantity 8k, so I wrote 8. Given quantity, the water quantity is 5k because I am calculating the percentage of water in the solution, so it will be 5k into 100, it will correspond to 500 by 8%. Come to this question, the answer of question number 1 is 300 by 8%, percentage of milk. Answer of question number 2 is 500 by 8%, percentage of water. I hope this thing is clear to you. I will now move on to the next concept. If you have not written it down, please jot it down.